All right, this is lesson 9.3, angles of elevation and depression. So to just remind you of the trig definitions, the sine is the opposite over the hypotenuse. That's where we get the so. Cosine, adjacent over hypotenuse, ca. And then tangent is the opposite over the adjacent, toa. That's where we get so, ca, toa. All right, angles of elevation and depression. As you can see, I have a horizon line up top, and I have a horizon line at the bottom. Remember that the horizon lines are parallel to each other. And when we talk about the angle of elevation, we're talking about the perception. We're talking about the perception of viewing from the home or whatever it is we're talking about. Here in this case, we're talking about a house. But the angle of elevation represents the degree that they have to look up. The degree that they have to look up. That would be an angle of elevation. Whereas the angle of depression, and if I look over here at the tower, pretend I were a person standing on top of this tower, the angle of depression would be the angle that I have to avert my eyes down, or the angle that I have to look downward. Remember that because these two lines are parallel, and we learned that alternate interior angles are congruent. Remember that the angle of depression and the angle of elevation are equal. Okay. So angles of depression or elevation. The first step is to draw a triangle or picture to fit the problem. Remember that this is going to be the length. This is the height above the ground. And then this is the distance or along the base. Most often you'll hear the distance from the base or along the ground. Okay? Make sure that you label the sides from the angle's view. This is no different than how we've set up all of our trig ratio problems. We always label the sides based off of the angle. And then I want you to identify the trig function you're going to use, set up your equation, and solve. Remember that we always use trig functions when we're trying to find an angle. We use trig functions for angle measures. Okay? All right, so example 1. At a point on the ground, 50 feet from the foot of the flagpole, the angle of elevation to the top of the pole is 53 degrees. So I have a flagpole, and 50 feet from that flagpole is the angle where my angle of elevation starts. So let me get us some pictures here. So 50 feet along the ground, here's my flagpole. So this is my flagpole. It says at a point on the ground, 50 feet from the flagpole, the angle of elevation to the top of the flagpole is 53 degrees. All right, so I'm trying to find the height of the flagpole. Well, I know from the picture that I have opposite over adjacent, so I'm going to use tangent functions. So I'm going to set up the equation. The tangent of 53 equals h over 50, and then I'm going to solve, and so I see that the flagpole is 66.35 feet tall. The second example says at a job site, a 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. So I know this measurement right here is 8 feet. Okay. I know that this ladder is 20 feet tall. I need to figure out what angle the ladder makes with the ground. I'm trying to figure out this measurement right here. Okay, so let's get some real pictures in here. So here is my triangle that I've drawn. Here's the ladder at 20 feet. This is the distance it is from the wall. And you'll see that this triangle picture is very similar to the one that I've drawn. So we've drawn our picture to fit the problem. The next thing that we want to do is label the sides. Well, I know that this is the hypotenuse. And I know from the angle, this is the adjacent. So using the hypotenuse and the adjacent, that's going to be the cosine function. So I'm going to set up my equation. The cosine of x equals 8 over 20. I am trying to find an angle measure. And all of you know that when we're trying to find a missing angle, we have to use the inverse function. So we're going to rewrite this as x equals the inverse of 8 over 20. So I find out that x is 66.42 degrees. Example 3. At a diving competition, a 6-foot tall diver stands atop a 32-foot platform. So this is the platform. It's 32 feet tall. But I have a diver up here, and the diver is 6 feet tall. The front edge of the platform projects 5 feet beyond the ends of the pool. The pool itself is 50 feet in length. A camera is set up at the opposite end of the pool, even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation to the nearest degree? So let's get a beautiful picture in here. Okay, so I have 32 plus 6 is actually 38. 32 plus 6 is 38. And then this distance right here, remember that this diver, this platform extends 50 feet. So I'm going to draw a dotted line here so you can see what we've done here. If the pool is 50 feet, I need to take 50 minus 5 to figure out that this actual distance here is 45. So I have 45 on the bottom or the base, and I have a height of 38. So I'm using the opposite over the adjacent. So I'm going to set up that the tangent of x equals 38 over 45. Now I need to find the camera's angle of elevation. And the answer is about 39.4 degrees. All right, so I have a couple of problems here for you. There are actually 5. What I'd like you to do is go ahead and try these on your own. Now we will cover these tomorrow in class, but it'd be great if you have them worked out. You'll see that number 3 is very similar to the ones that we did in class yesterday, as well as number 2. Okay, so this is what I'd like you to try on your own.